Next part is about async and await and incrementally loading data. So it's actually a few tips on async and await to start with. One of the important things I think is being able to support cancellation on your tasks. So you're now going to create our own tasks which run asynchronously, and being able to support cancellation on this is quite important, because your tasks might be fired off and keep on running and running and running, and if something goes wrong in there, or you end up in some kind of loop, or operation takes longer than expected, you might want to cancel that task. I'm trying to think of an example here, but let's say you are on a page in your application which does some heavy image processing. So you're on a page, and on that page you're trying to apply some shaders and some effects on your images, and that can take quite some time, especially if you're on not too high-end machines, which you always have to take into consideration when building Windows 8 apps. Imagine now that the user, well, you of course want to do that async, because you do not want the UI to look blocked while you're doing that. But imagine your user navigates away from that page while your tasks are still running. Well, one thing you could do is just let those tasks run, but it's actually of no use. Your tasks will run, but they will never be able to show their output, because the user's already away from that page. He actually, by navigating away, said, I don't want this anymore. And secondly, the fact that the async task is still running and doing the heavy image processing is making your computer slower. Your PC has less memory and less CPU power for the rest of the application left. So a good idea here is to support cancellation, which can be done through cancellation tokens. That's actually not Windows 8 specific, by the way. It's existed for quite some time. And I'm quickly going to show you how you can do that in your own application when you create your own tasks. So it's actually quite simple. Once you create a task, you have to ensure that that task accepts a cancellation token. And in your task, you are the one that's responsible for checking that cancellation token from time to time. So it's quite important that you are now creating a task that's cancelable. So you are the one that is responsible for checking if code somewhere was called to cancel your running task. Okay, let's have a look at that. Let's see. I've actually just included some dummy code for this to show you, but it's quite easy actually. So what I've done here, I'm first going to look at the task actually. So this is a task that can be cancelled. What I do, I actually just fake a long running operation. Well, I count to 1000 and I delay for a second each time, so this would take about 1000 seconds. But I pass in a cancellation token. So what happens is, every time on each run, I am responsible, or my task at least is responsible for checking if somewhere cancellation was requested. So from anywhere in my code, through this cancellation token, cancellation can be requested. If that is the case, I should throw an exception, and the exception you throw is of type operation cancelled exception. So if you catch that one is the result of this being called when this has been cancelled. So if you call this, you will end up here, your task will be cancelled, and you won't be in this long running operation anymore. So only thing I do is a method that calls and cancels that task. Say, well, the result here is the result of test task cancellation. Let's put a breakpoint there. And what I do is actually quite simple. I first of all create a cancellation token source, and I call and cancel the task passing in the token. So that's the cancellation token I check every time in my long running task. I immediately cancel this. This should result in the task being run once, and the second time the cancellation should be there, and I should get the operation cancelled exception, resulting in my task being cancelled and me getting rid of the long running operation. I am going to comment out this so we can concentrate on the task being cancelled. Let's see, I'm going to put a few breakpoints here. And like that. So now I just have to call this. And I'm going to do that just for demo purposes when I start my app, because that's when load categories is executed. So where are we at? My test task cancellation has been called. First time, this should, if everything goes well, not happen. So let's see. There we go. And I continue. Second time, this should happen because now this has been executed. My operation is cancelled. So the result of this long running task is cancelled, and I no longer have to wait for all this to be completed. The nice thing is these cancellation token sources, you can have those actually anywhere in your app. If you take again the example I had with the image processing, you could say you could say when I navigate away, I say cancellation token.cancel. But you could also state that your user has the ability to cancel when he wants to from anywhere in the app if you keep your cancellation tokens in some sort of container somewhere. That's another way of working with this. Again, a lot of this depends on how you architect your app and what the requirements are. But these cancellation tokens actually come in quite handy a lot if you want to keep your app performant. Okay, two other things. First one, that's actually just a tip. Your methods, your async methods, are automatically marshaled back to the UI thread once they are completed. So if you use an async method and you await them once the method has been completed, you're back on your UI thread, which is why it's very easy to have a method which calls, which works on something that's directly bound to your UI. You do not have to marshal that back to your UI thread. It works out of the box. However, you might not want this. In some cases, for example, if you have an async method which just does a bunch of, let's say, a bunch of algorithms, or let's say it otherwise. You have an async method which calls for a bunch of categories from a service. But before you bind those categories to that service, you still want to do a bunch of business logic on those. You typically don't want to do that business logic while you're in your on your UI thread, of course. So one way is to start another task on the collection you get back. Another way is to state, well, once my async method returns, I do not want to have it marshaled back to the UI thread. So you can still do other stuff on that, on other threads, without it blocking your UI thread. Which is actually quite simple, because the only thing you have to do is add the configure await method false to the calling of your async method. And that's all you need to do to ensure it's not marshaled back to the UI thread. Now all of this, by the way, is also in the parallel tasks library, which was already available earlier, and a lot more. So I've picked out 2 more that might be interesting. Waiting for any or all tasks to complete. That's something you actually get a lot. You could say, well, I want to wait for all my tasks to complete, so I just fire them in a row. Await task 1, await task 2, await task 3. What actually happens then is that you're not, well, you are waiting for all those tasks to complete, but you are firing them one by one after each other. So that means it takes up the time for the first to complete, plus time for the second, plus time for the third. Now you can also fire them in parallel. So for example, if those are actual service calls, that should be a lot faster, because they then return. And by using the task.whenAll declaration, you can actually say, when all these tasks have been completed, then continue with some other code. And the other way is firing a bunch of tasks and continuing when one of those has completed, and that's the whenAny method you use for that. And there's actually quite a lot more. These are just a few I want to show you. I'm not actually going to run the code anymore, because it's quite obvious what it does, but I do want to show a few other options you have. So you can see here you have whenAny generic, whenAll, wait_any, wait_all, and there's delay as well, which is quite easy to have an async delay in your code. So there's quite a few options here, and you have even more when you use Task Factory. But I think that would lead us a bit too far now. But just, I think the important part here is that you know that, in essence, there's a lot more to async and await than just those async and await keywords. It's all just parallel tasking underneath the covers. So you can use everything you know from the parallel task framework. Okay. And I've just shown you this. Okay, this small session is about incrementally loading data. I actually have exactly 1 slide on this, because it's all code. It's much more interesting to show this on code. So I'll immediately go to the demo. Let's see if I can find it. I'm pretty sure it's not in here. So I'm going to open it. A requirement you often have in applications is the requirement to load data incrementally, paging data typically. Well, in Windows 8, it would be quite nice if you could have a grid view that automatically loaded data when you kept on scrolling. Luckily, this can be done quite easily, because everything that implements list view base, so that is your list view, your grid view, or any other control you might derive from it, is linked to the I support incremental loading interface. So let's have a quick look at that one. I support incremental loading. This is the one that does all the magic. What actually happens is your grid view, your list view listens to this. If the collection, your grid view or list view, is bound to implement this interface, it will automatically load more data once it reaches the end of scrolling. So what you have to do is you will have to create your own collection type for this, of course, because you have to. There's not a built-in collection, as far as I know, that implements this interface. So you will have to implement this interface on your own collection type, and this interface will obligate you to implement two things, which is a has more items boolean and a load more items async method. It's quite obvious what these do, of course. Load more items async is what will be called by your list view or grid view whenever your scroll view reaches the end, or almost the end. And has more items is the one that will make sure it is called or not. If has more items is false, then it won't try to get more data. So how do you do that? In this case, I've created a collection specific for Flickr data, which is an observable collection that works on the photo data common class. Photo data common, there's nothing special about that. That's just a wrapper class around what I get back from Flickr. So it's just a class with a bunch of properties you get back from the API. So there's nothing special about that. The special part is that this collection implements I support incremental loading. So what do I have to do here? For now, I'm stating that it always has more items. If you want to implement this more thoroughly, this would typically be something you have to call yourself. So you will have to have some logic which will tell you that there's more items on the server or not. Typically, you can do that by checking whether or not the page size you're requesting has been completely fulfilled or not. That's one more or less easy way to do it. So what you do then, the load more items async method is the one that will be executed automatically. So in this, you will have to call a method to actually load the next bunch of data from, in this case, the Flickr API. You do that through an async method. This is another way to call async methods. Task.run instead of just running something that's already a task. So what I do here is I say run me something that will return a load more items result. And that is what I am going to run. So I'm running an async method, which I define here instead of a bit lowering my code in a different task. So it's actually a shortcut of writing this. Say, well, every time my async call or my get load more items async call is asked for, I will execute the get page method. And I will pass in the current page I'm on and the page size I want returned. So the get page method, what's that? That actually just calls the Flickr API, including the page size and the page index. So I get back the correct data. What this does is it's just a call to an HTTP client, and afterwards it parses the XML result I get back to a bunch of photo data common items. So that's what it does, it's just a call. And then I use the dispatcher to dispatch this back to my UI thread. I have to do this in this case because this collection is bound directly to my UI. Otherwise, this will fail. We'll get an it's called unauthorized thread access exception. What I do here is, well, I go to all items in my result and I add them to myself, so to the observable collection of photo common data that I am in this case. When this is done, I say, well, the current page should be one more now, because next time I will have to fetch the other one. And then I just return the load more items result, which is what is suspected for the load more items async method. And I pass in the number of items that I got back. That's what it uses to ensure how far, how many items it must add, how far the scroll viewer should continue to count. And that's about it actually. So that's actually two things you have to implement. Has more items and load more items async. And now all I have to do is ensure that my grid view is bound to a collection of this type. As you can see, you can of course build on this. You can make this generic, you can make this even accept some kind of action to load the rest of the data through another class, maybe. So where did I implement this? I have a incremental load view model, and all it has is one property, photos of this type, and that is bound to the incremental load view, which contains, let's have a look at this, a grid view bound to photos, of which the template is nothing more than an image. So if I run this, there we go, and I go to the correct page, which should be this one. It should automatically start loading. This is a call to Visug. And if you look here below, I think it's still, yeah, it's just visible. While I keep on scrolling, it will start, up, there we go. It will automatically keep on loading and 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 loading. And it will just continue to do that infinitely at the moment, because I said there's always more items.